In this video, we're discussing hypothesis testing, and essentially what we're discussing is the 4 possible outcomes that can occur when you test a hypothesis using the approach that we use in class. So essentially, we have to decipher this table here. So let's try to go over the basics. The left-hand column here is telling you what you decide, what the researcher decides, right? And there's only 2 possibilities because every hypothesis test we conduct is really just testing whether the null hypothesis is true or not, right? So basically, we say that we either reject the null hypothesis or we don't reject the null hypothesis. That's the only 2 decisions available to us because we're testing the null hypothesis. We can either reject it or say that we don't reject it. Now, the truth in reality can only be one of 2 things. Either the null is true or the null is false, right? There are no other options, right? Either the null is true or the null is false. It's a simple statement, so it can't be sort of partially true or partially false. It's either all true or all false, and that's basically it. That leaves 4 possible outcomes. So here we have this box labeled a type 1 error. So let's first talk about why it's an error, and then we'll describe what it means to be a type 1 error. So if the null hypothesis is actually true, is it a mistake to reject it? Yes, it is a mistake, right? So if it's true, you should not reject it, and that's why it's considered an error. And we're going to label that the type 1 error. How about this box? Well, the null hypothesis is false, so we're saying in reality it's false, and you come along and you reject it, and that's a good choice, right? That's a good decision because, of course, if it's false, it should be rejected. What about this box? The null hypothesis is true. You fail to reject the null hypothesis, right? So in other words, it's true and you don't reject it. Well, that's good, right? Because if it's true, you shouldn't reject it, right? That would be a mistake to reject it. So it's good that you didn't reject it, right? Because it is true and you should not reject it then. And then finally, the type 2 error. The null hypothesis is false, and yet you fail to reject it. So in other words, this is a mistake because in reality, the null is actually false, and you have this opportunity to reject it or overturn that falsehood, and you fail to do so. So that means essentially you've committed an error, right? And we're going to label that the type 2 error. So let's first talk about a couple of things about the null hypothesis, just as a reminder. Remember that we normally start out the process assuming the null hypothesis is true. So you could kind of think of it as something that's been around for a while, even though this isn't always the case, but you can imagine it's something that's been around for a while that society has believed, right? We certainly don't want to falsely overturn that, right? Or mistakenly overturn that, right? So in other words, if the world is out there believing something that actually is true and we come along with our fancy science and we reject it, then we've basically made the world less wise, less knowledgeable with our science, and that's really not the role of science, right? So that would be a terrible mistake. So type 1 error we're going to view as the more severe of the 2 errors. In the type 2 case, basically there's this falsehood out there, right? There's something that people believe that isn't true, and we have this opportunity to overturn that falsehood, to make the world wiser, but we don't take the opportunity. We miss the opportunity to improve the world. But the world hasn't changed really for the worse, right? It was kind of basically already believing this thing that was false, and we came along and had an opportunity to fix that, but we didn't. So the world kind of stays on its path, and even though maybe we had the opportunity to do something that we failed to do, it doesn't mean that we've actively made the world worse. So the way I want you to think about this is that the type 1 error is worse because you're actively making a decision using science that actually is a negative for society, right? You don't want to do that. You don't want to use science to overturn things that are true that people already believe, right? So if the world is believing something, you come along and actively make it less intelligent or less knowledgeable with your science, you've sort of violated the whole principle of scientific hypothesis testing. So we're going to view this error as more severe than the second one. The second one is a missed opportunity. The first error is actively making the world worse. Okay. So again, just a redefinition, the type 1 error is rejecting a true null hypothesis. So that's what it means, right? You rejected something that was true. A type 2 error is not rejecting a false null hypothesis, right? So a missed opportunity, as I said before, actively making the world less knowledgeable versus missing an opportunity to advance the world's knowledge, right? Like you had an opportunity to do something good, but you didn't take it, right? I would like to think of it as maybe somebody, actively doing something terrible in the world. What's worse, that or somebody sort of being a couch potato and not making use of his potential? Obviously the couch potato, while that's not a wonderful way to spend your life, it's certainly better than actively making the world worse, right? So again, we're going to view the type 1 error as more severe. Some people like to talk about the criminal justice system in the United States as a basis for this. The null hypothesis there is usually that a person is assumed innocent until proven guilty. So the type 1 error in that case is convicting an innocent person. Most of us think that that's a more severe error than the second one, which is not convicting a guilty person. And again, this is nice, I think, because it also emphasizes that even though the type 2 error is viewed as less important or less severe, it's not to say it's unimportant, right? Because of course, when you don't convict a guilty person, there's an injustice there that's occurred. Obviously, convicting an innocent person, though, seems to be a greater injustice to most of us. All right, so here's an example with a concrete hypothesis. So it says, for example, the Department of Transportation in Florida claims the average distance driven by Florida drivers is less than 40 miles per day. So I want to point out that because it says less than 40 miles per day, this is actually an alternative hypothesis, right? It doesn't have that sort of equality that's required for the null hypothesis. So when we talk about the null being true, the null is the idea that people drive 40 miles or more versus the alternative where they drive less than 40 miles. So our decision to reject the null, in this case where the null is true, it would mean that people actually drive 40 miles or more each day, but you came along and you rejected that statement, right? That would be the type 1 error, right? For the type 2 error, it would be that people do not drive 40 miles or more, but you don't reject that, right? So in other words, it's not true that people drive 40 miles or more. Remember, that's the argument that's going to win by default unless we can prove otherwise, and you don't reject it means you basically let this false belief stand, right? So in that case, it actually means that people drive less than 40 miles a day, but you don't reject this statement, which means you, as a result, don't support the actual one that's true. Now, of course, the other two are correct decisions because, of course, you're rejecting the null when the null is false. So I won't talk about those, but this is just a concrete example of how you would word the type 1 error in these cases. Let's look at one more case. Consider a fire alarm as a hypothesis test, right? This is a very, I think, instructive example. So the null hypothesis would be that there is a fire. That would be your automatic default assumption. And the alternative is that there is no fire. Now, you might say, well, why is that the case? Why can't we switch that around? You certainly could, but our goal here normally when you're setting up a hypothesis test is to try to make sure that the worst error is the type 1 error. So let's talk about it. If I set up my null hypothesis this way and my alternative this way, what kind of error would happen if you ignored a fire alarm when there is a fire in the building? So there is a fire in the building would mean that what? HO is true. And if you ignore it, you're essentially rejecting the fire alarm. You're saying, oh, I don't believe that. It's ringing. It's probably just a false alarm, right? You reject it. So you've made a mistake. And you've made a type 1 error then, right? Because if there is a fire, the null is true. And by you ignoring it, you're basically rejecting a true hypothesis. Now look at the second one. What kind of error would it be to exit the building due to an alarm when there is no fire? Well, if there's no fire, essentially the null hypothesis is false, right? So it's saying there is a fire, but here it says there's no fire, and you exit anyways, which means you don't reject it. You don't ignore the alarm when you should here in this case, right? Because there's no fire. So this would be the type 2 error. And then it comes down to this question, which error is more harmful? Well, I think the first one is more harmful, right? Because if there's actually a fire and you don't walk out of the building, you could end up getting seriously harmed or killed in the fire, right? But here, of course, you're going to be inconvenienced, and maybe it's not great for productivity levels for workers, let's say, but outside of that, there's no really life or death situation going on. So I would argue that the type 1 error is more dangerous here, and that's exactly why you would set up the hypotheses in this way, because you want to make sure your type 1 error is the worst of the errors to avoid it then. And the reason why we're going to avoid it is we're actually going to set limits on that type of error, right? So we're going to try to control it and prevent it from occurring. So this comes to the idea of the probability of a type 1 error. So when HA uses the symbol not equal to, right, the probability of the type 1 error is equal to the significance level alpha. So all you have to do is look at alternative hypothesis and say, hey, what symbol is it using? If it uses a not equal to symbol, it indicates a two-tailed hypothesis test. And whenever that's the case, the probability of a type 1 error is going to be set equal to the significance level, which is alpha. Now, in the other cases, and the only other cases that exist are a left-tailed test or a right-tailed test, and that's when HA uses either a less than or greater than symbol, the probability of a type 1 error is going to be a maximum of alpha, or in other words, at most alpha. So, for example, if alpha was 5%, in this scenario where you have a not equal to symbol for the alternative hypothesis, the probability of a type 1 error would be equal to 5%, whereas in the one-tailed case, it's going to be a maximum of 5%, meaning the actual probability of a type 1 error could be lower depending on what the true mean is, right? But, again, it won't be any higher than 5%. So it'll go up to 5%, but no higher than that. And so that's essentially it. And that's all you need to know for now about the probability of a type 1 error.